In the cosmic theater of our solar system, Mercury is the elusive actor, closest to the Sun, yet often overlooked in the dazzling spotlight of its parent star. It's a planet that rarely takes center stage, slipping in and out of view, shrouded by the Sun's intense brilliance. Often, Mercury is lost in the Sun's glare, making it a rare sight even for seasoned astronomers. Its fleeting appearances at dawn and dusk only add to its air of mystery, as if it's playing a cosmic game of hide-and-seek. Unlike Jupiter's swirling storms or Saturn's majestic rings, Mercury is a world defined by extremes. One hemisphere is scorched by relentless sunlight, reaching temperatures hot enough to melt lead, while the other is plunged into freezing darkness, colder than any place on Earth. Its small, unassuming size hides a massive iron core, proportionally larger than any other planet's. This dense heart challenges our understanding of how planets form and evolve, raising questions that scientists are still striving to answer. Once dismissed as a dead, cratered rock, Mercury has revealed a surprising complexity. Its surface is scarred by ancient impacts, but also shaped by mysterious cliffs and ridges that hint at a restless interior and a dynamic past. Every crater, cliff, and scarp is a record of the solar system's violent youth, a time when collisions and chaos sculpted the worlds we see today. Mercury's battered face is a living archive of cosmic history. Studying Mercury is like peering through a window into the forces that shaped all the planets, including our own Earth. By unlocking its secrets, we gain insight into the origins and evolution of the entire solar system. But getting close to Mercury is a monumental challenge. The Sun's gravity pulls relentlessly, and its searing heat threatens to destroy any spacecraft that dares to approach. Missions to Mercury require ingenious engineering and unwavering determination. For decades, Mercury remained more mysterious than even the distant gas giants. Its secrets were locked away, hidden in the blinding light and deep shadows. Yet, human curiosity has driven us to uncover its secrets, one mission at a time. Each new discovery brings us closer to understanding this enigmatic neighbor, reminding us that even the smallest worlds can hold the greatest mysteries. The James Webb Space Telescope, JWST, is humanity's most powerful eye on the universe. Its golden mirror and sunshield let it see the faintest heat from the earliest galaxies. But why not point it at Mercury to solve its mysteries? The answer: it would destroy the telescope. JWST's instruments must stay incredibly cold, shielded from the sun, Earth, and moon. To look at Mercury, Webb would have to face the sun, flooding its sensors with heat and blinding them instantly. The observatory would be ruined in moments. Webb is designed to look out into the cold, dark universe, not in toward the sun. Its orbit at Lagrange Point 2 keeps the sun and planets safely behind its shield. Mercury and Venus remain forever in Webb's forbidden zone, invisible to its gaze. Mercury's story has been revealed by robotic explorers, not telescopes. Mariner 10 in the 1970s gave us our first close-up images, showing a cratered world with unexpected features. For decades, those grainy photos were all we had. Then came Messenger, which orbited Mercury from 2011, mapping its surface and rewriting our understanding. Now, BepiColombo, a joint European and Japanese mission, is nearing Mercury, ready to study both the planet and its magnetic field. These missions are triumphs of engineering, overcoming the sun's pull and Mercury's heat. Getting there requires years of gravity assists and careful planning. Once in orbit, spacecraft must survive blistering temperatures and radiation. The teams behind these missions are true pioneers, revealing a world Webb can never see. Each mission brings us closer to understanding the sun's closest companion. One of Messenger's most dazzling findings: Mercury's surface may be laced with diamonds. The planet's crust is rich in graphite, carbon that, under the pressure of relentless impacts, could transform into diamond. Billions of years of asteroid bombardment may have created a layer of tiny, industrial-grade diamonds mixed into the dust. Imagine a world where the ground sparkles with microscopic gems. BepiColombo will search for the spectral signature of diamond, testing this extraordinary theory. If confirmed, it would reveal Mercury as a cosmic forge, transforming raw materials in extreme ways. Even the most barren worlds can hide scientific treasures. Mercury is not just a hot rock. It's a planetary alchemy experiment. Mercury, the closest planet to the Sun, is a world of extremes. Its sunlit surface can reach temperatures hot enough to melt lead, making it seem like an utterly inhospitable place. With no atmosphere to shield it, Mercury bakes under the relentless solar glare, its rocky terrain scorched and barren. But hidden away at its poles, Mercury guards a chilling secret: water ice, preserved in the most unlikely of places. How is this possible? Unlike Earth, Mercury's axis is almost perfectly upright, tilted by less than 1 degree. This means that some deep craters near the poles never see sunlight. Their interiors remain in permanent shadow, untouched by the sun's heat for billions of years. These shadowed regions are among the coldest places in the entire solar system, colder even than Pluto at times, cold enough to preserve ice for eons, despite the planet's proximity to the sun. Over millions of years, comets and asteroids bombarded Mercury, delivering water molecules that settled into these frigid traps. Once there, the water became trapped, locked away in these cosmic freezers, protected from the sun's intense heat by perpetual darkness. The first hints of this hidden ice came from Earth-based radar, which detected bright reflections at Mercury's poles. Later, NASA's Messenger spacecraft confirmed the presence of these icy deposits, finding thick layers of water ice buried beneath a mysterious, dark, insulating material, possibly organic compounds or dust. This discovery was astonishing. It proved that water can survive in the most hostile environments, even on a planet where daytime temperatures soar above 400 degrees Celsius. For future explorers, this ice could be a game changer, a vital resource for drinking water, breathable oxygen, and even rocket fuel, making long-term missions possible. Technologies could one day extract water from these icy deposits, supporting human or robotic outposts and enabling deeper exploration of the solar system. The idea of mining ice in Mercury's eternal shadows is no longer pure science fiction. It's a real possibility, inspiring scientists and engineers to dream bigger. Mercury is truly a world of fire and ice, a planet of dramatic contrasts, where the hottest and coldest places exist side by side. As we continue to study Mercury, we're only beginning to uncover its secrets that could change our understanding of the solar system. Its frozen water transforms Mercury from a planetary curiosity into a place of real potential, holding promise for science, exploration, and perhaps even the future of humanity beyond Earth. Alongside water ice, Messenger found organic molecules, carbon-based building blocks of life, hidden in Mercury's polar shadows. Delivered by comets and asteroids, these organics form a dark layer atop the ice, helping it survive. Their presence shows that the ingredients for life are widespread, not unique to Earth. These molecules endure space and impacts, settling in protected craters. The combination of water and organics raises a tantalizing question. Could life exist here? While Mercury's surface is too extreme, its shadowed craters are more stable. Extremophiles on Earth thrive in harsh places. Could something similar exist on Mercury? BepiColombo will analyze these deposits, searching for clues to the chemistry of life's origins. Even on the sun's doorstep, the seeds of life may be waiting in the dark. Mercury's greatest mystery lies within its enormous iron core. The core makes up 85% of the planet's volume, far more than Earth's. Why? One theory: a giant impact stripped away Mercury's outer layers, leaving a dense metallic remnant. Another Mercury formed close to the sun, where only heavy elements could survive. BepiColombo aims to solve this puzzle, revealing how planets form near stars. Messenger found Mercury's core is partly molten, generating a weak magnetic field. This was a surprise for such a small, old planet. Mercury's liquid core means it's still geologically active, with a warm heart beneath its battered surface. Its iron heart is a key to understanding planetary evolution. Mercury is shrinking as its core cools, causing the crust to buckle and form giant cliffs, lobate scarps, across its surface. Some scarps cut through young craters, showing the planet is still contracting today. Mercury is one of the few tectonically active worlds in the solar system. Its surface also reveals a violent volcanic past, with explosive eruptions leaving bright deposits and vast lava plains. These eruptions were driven by volatile gases trapped in the magma, blasting material high above the surface. Mercury's geology is dynamic, shaped by both internal contraction and volcanic fury. It's not a static relic, but a world still evolving. Studying its geology helps us understand the life cycles of rocky planets. Mercury is a living laboratory for planetary change. If Webb can't see Mercury, what is its true mission? The James Webb Space Telescope, humanity's most advanced eye in the sky, was never designed to look at our innermost planet. Instead, its purpose is far grander. Webb is built to answer some of the deepest questions we have ever asked about the cosmos. Webb is a time machine, peering billions of years into the past to study the first stars and galaxies. By capturing faint light that has traveled across unimaginable distances, Webb allows us to witness the birth of stars, the formation of galaxies, and the evolution of the universe itself. It's as if we're looking back in time, seeing the universe as it was just a few 100 million years after the Big Bang. It's rewriting our understanding of the universe's origins and the potential for life elsewhere. Every new image and data set challenges what we thought we knew, revealing new mysteries and possibilities. Scientists are constantly surprised by what Webb uncovers, from unexpected galaxy shapes to hints of water in distant planetary atmospheres. While Mercury remains out of reach, Webb studies the outer planets and distant worlds, expanding our cosmic perspective. Its powerful instruments can analyze the atmospheres of exoplanets, search for signs of habitability, and even detect the building blocks of life far beyond our solar system. Meanwhile, BepiColombo is set to unlock Mercury's secrets, its diamonds, ice, and iron heart. This joint mission by Europe and Japan is braving the sun's intense heat to map Mercury's surface, study its magnetic field, and uncover clues about how rocky planets form and evolve. Science advances piece by piece. Webb looks outward, while robotic probes brave the sun's glare. Each mission has its own unique challenges and rewards, and together they help us build a more complete picture of our place in the universe. Each discovery, from water on Mercury to galaxies at the edge of time, enriches our knowledge. The more we learn, the more we realize how much there is left to explore, both close to home and in the farthest reaches of space. Mercury's mysteries endure, but our curiosity is relentless. We are driven by a desire to know, to push boundaries, and to seek answers to questions we haven't even thought to ask yet. We will keep sending explorers, determined to understand every corner of our solar system. Each mission, each discovery, brings us closer to unraveling the secrets of our cosmic neighborhood. The quest to know Mercury and the universe continues, fueled by human ingenuity and an unending sense of wonder.